So hello, dear colleagues. Again, can you hear me? I hope yes.
Yes, hello.
Yes, we can hear you.
Great. So welcome to Physics 161 recitation session. My name is Marat Kaikanov. I am holding a position of postdoctoral scholar in physics department. I'm PhD in physics. I'm specialist in accelerators. Here at Nazarbayev University, I'm a supervisor of the accelerator lab, and I'm here right now in the accelerator lab. This is a big room. So later when you are all in campus, you can ask me and I will show you the accelerator room in person. So, I'm going to be your instructor of Physics 161 recitation session in the first half of the semester. And today it's our first meeting. So I see that we have the increasing number of the participants. But anyway, it's 1 minute past 2. I will continue. So it's our first meeting. And at the beginning, let me briefly provide you the information about our recitation sessions. So I'm going to prepare a list of the problems by myself, and I'm going to send you the list of the problems in advance before each session. So you would have a time to check the list of the problems. You will have a time to try to solve the problems by yourself and prepare some questions. So our sessions are free to attend. And also I'm going to record each session. Probably some of you would like to see the session again. So just ask me and I will send you the video. You're also welcome to interrupt me whenever you wish during the session, ask your questions. We discuss the concept of Physics 161, all the formulas, and the main idea is that there is no bad question about physics at all. So anything you would like to ask me about physics, please ask. If I cannot answer you immediately, I will discuss with you the answer next session. So this is like ongoing process of discussion. So I'm going to use my second camera and piece of paper. I will show you how to solve the problems. So any questions at the moment? No?
No, I guess.
Okay, thank you. So then let's solve some problems. Today we're discussing coordinate systems and vectors briefly, since this is the first session. According to syllabus, you covered those parts already at the lectures. So now let me change my camera. So I hope you can see the problem. So let's get started. Excuse me. So in the first problem, we have 2 points in a plane and they have polar coordinates 2.5 meters 30 degrees and 3.8 meters 120 degrees. We need to determine first the Cartesian coordinates of these points and B, the distance between them. So the first problem is to warm up, to remind you the main concept, main idea of the coordinate system. So first, let's collect what is given here in the problem. So we have a first point. This point has a polar coordinates that are represented by 2 numbers. First number is 2.5 meters, and second number is 30 degrees. And second point has also coordinates in polar coordinate system in a polar form. It's 3.8 meters and 120 degrees. We need to determine. So first, what we need to find. We need to find Cartesian coordinates of these 2 points in the form of x and y. So for the first point and for the second point. Okay, this is question A. And B, we need to find the distance between these 2 points. Okay, so we know that solution. Let's briefly discuss at the beginning the idea of coordinate system. So in order to define the position of the object in space, we introduce some coordinate system. So we have 2 axes. They intersect at some origin. In general, in rectangular coordinate system, we have x-axis and y-axis. In plane, in space, we have third coordinate axis z. So we also can represent the position of the object with different parameters, not x, y, but also distance of the point from the origin, and we call this coordinate r, and the angle theta with respect to the positive direction of x-axis. So that's how we can also define the point, the distance from the origin and this angle. Okay. So in our problem, we have 2 points, and we have to find out rectangular coordinates of the points, 2 points in xy form, and we are provided by, and we have these 2 numbers, distance and angle. Questions? So you are also welcome to unmute yourself. We can discuss right during the solving process. So let's draw at the beginning some sketch with these 2 points. So we will try to estimate the position of the 2 points. The first point is 2.5 meters far from the origin. So here is the origin, and the angle is 30 degrees. So approximately the point 1 is somewhere here. So this is 30 degrees. This is 2.5 meters, 30 degrees. And second point has a position 3.8 meters from the origin, and the angle is 120. So let's draw this angle approximately here. So it's 120 now degrees. Here is the distance, 3.8. So here is a point 2. Now we need to find x and y coordinates for these 2 points. Okay. So in general, so any suggestions how to find these components? So let's say for the point 1.
We can use cosine and sine of the angle.
Yeah, correct, great. So from here, we can say that if we need to find x and y components of this point, we can, so x component is this distance. So from this triangle, x equals to what, r? Please check me. R times.
Isn't it y component?
Oh yes, it's y. Excuse me. So that's why I asked you to. Oh no, it's correct. It's x. It is x when cosine it, and so this is y component. And this is x. So and for y component, it's r times sine, not 30, but theta. Excuse me. Sine theta and sine theta. Correct? I think yes.
Yes.
So for point 1, we have these numbers, r and theta. So let's just substitute the given numbers into this expression, and we will find the components for the point 1. So x1 is r1 times cosine theta 1. In our case, this is 2.5 and 30 degrees. So that would be 2.5 times cosine 30 degrees. So numerical value is 2.17 meters. So y component, again from here. So we just need to multiply the distance r2, which is here, times, excuse me, we're still working with point 1. So r1 times sine theta 1. The numerical value would be 1.25 meters. So the coordinate of the point number 1 in a rectangular coordinate system. So the coordinates are 2.17 and 1.25 meters. So here is the answer. The first for the point number 1. Okay, the same calculation we can do for the point number 2. So for the point number 2, Okay, so x2 would be equal to r2 times cosine theta 2. Y coordinate for the point 2 equals r2 times sine theta 2. So substitute all the numbers. We have them at the given part of the problem. And we can calculate this coordinates. So numerical values are minus or negative 1.9 meters and 3.29 meters. Okay, so in xy form would be negative 1.9 and 3.29 meters. So here we have the coordinates in rectangular coordinate system for the second point. Okay, now we need to find the distance. In part B of the problem, we need to find the distance between these 2 points. So here, that's distance between 2 points. So let me briefly remind you. So this is part B of the problem. So if you have in a rectangular coordinate system, if you have 2 points, for example, 1 point and second point, yeah, so let's call this point number 1 with coordinate x1, y1, y1, and let's say this is a point 2 with coordinates x2, y2. So what would be the distance between these 2 points? Well, in general, this guy is x2, this guy is x1. So the length of this part is x2 minus x1, agree? So now this guy is y1, this one is y2. So this length is y1 minus y2. Now, this is a distance between these 2 points. And look at this figure. So using the Pythagorean theorem, we can say that the distance squared equals to x2 minus x1 squared plus y1 minus y2 squared. Since these values are in squared, we can replace them with each other. So the value would be the same. So in our particular case, we have the components of 2 points. So let's just substitute these numbers into this expression. So this is a general expression for 2 points. And we will find the distance between them. So part B again. So the distance is square root x1 minus x2 squared plus y1 minus y2 squared. Agree, substitute numerical values here. So this is x1, this is y1, this is x2, this is y2. So numerical value would be square root of 407 squared plus 204 squared. So the answer is, distance is 4.55 meters. So here is the answer for the part B of the problem. Okay, questions, please. If no question, then let's solve the next problem. So now we have again the polar coordinate of certain point, and they are the coordinates are 4.3 centimeters and theta is 214 degrees. First, we need to find its Cartesian coordinates x and y, and then we need to find the polar coordinates of the points with Cartesian coordinates minus xy, minus 2x, minus 2y, and d, 3x, and minus 3y. So in the second part of the problem, we would have Cartesian coordinates of the points, and then we will have to find the polar coordinates. Okay. What is given here? So r for the first point is 4.3 centimeters. So the theta angle is 214 degrees, and we need to find. So first we need to find Cartesian coordinates of this point. And in part B, Now it is given that some point has a Cartesian coordinates minus x and y, minus x and y. So we will use these numbers. We will find these numbers at the beginning, and then we will use these numbers. And the second point would have this Cartesian coordinate. And for this Cartesian coordinate, for this point, we need to find polar coordinates. Okay, A, B, C. So in case C, we have given point with coordinates minus 2x, minus 2y. So relative to these initial values. And for now, for this point, we will have to find r and theta. And we also have part D that you will solve by yourself at home. So we have the point 3x minus 3y, and we need to find r and theta. Okay. So again, that was in previous problem. We have some point. We have the distance. So this is xy coordinate system. So here is the origin. So in the problem, at the beginning, it is given that the point is located somewhere. So in our case, so let's do it in general. So we have Cartesian coordinate system, and we can represent the position of the point as a distance from the origin and angle theta. And in order to find the Cartesian coordinates, we need to apply this formula. So x component equals r cosine theta, y component equals r times sine theta. So in case of this given problem, so at the first part, so we use these numbers and we can find x component, so that we equal 4.3 times cosine 214. The numerical value is, so if you substitute the numbers, that will be equal to 4.3 times negative 0.83. And this is equal to minus 356 centimeters. Okay, this is x component. So y component is r times sine theta. It is equal to 4.3 times sine 214 degrees. So numerical values are 4.3 times negative 0.56. And the answer is minus 2.4 centimeters. So this is x component, x coordinate, and this is y coordinate for the point. For the point that has this coordinates in the polar system. Okay, now we have, and by the way, you can also analyze at the beginning the position of the point. So you can predict at the beginning that the point would be located in the third quadrant, agree? So this angle is 90, this one is 180, so this is 170, so 214 degrees is somewhere here. So at the very beginning, you could predict that your point would be located in the third quadrant. And when you check your obtained results, so if you would like to double check, just analyze the obtained components. So x component is negative, y component is negative, and exactly correct quadrant here. So it's negative x, negative y. So our answer seems to be correct. So now we have the point which has a coordinates minus x and y. So, and we can use a numerical values already. So minus x is 3.56 and plus y is minus 2.4. Agree? So now we have Cartesian coordinate of some point. We need to find the distance from the origin and the angle. So we need to do inverse operation. So now we have some point x and y, some point that has x and y coordinate like that. Agree? Now what would be the distance? This r. So suggestions. So this would be square root of x squared plus y squared, and this angle theta we can say that tangent theta here equals to y over x. Agree?
Yeah.
Thank you. So this is so this is the way how to find polar coordinates when you have Cartesian coordinates of the point. Okay, so also very useful formula. That was here reverse operation, and here direct operation. Now let's substitute the numbers for this point into this system of the equation. So for this point, the distance from the origin equals to 3.56 squared, 3.56 squared, plus negative 2.4 squared. So we need to find the square root from this sum. And obviously the value would be always positive because this is a distance. So, and the answer is 4.3 centimeters. So as you can see, the distance is the same as it was at the beginning because we just changed the sign of one of the components. So we just changed a quadrant for this point. Okay, so distance is 4.3 centimeters. Now, in order to find this angle theta for this point, let's use this formula. So that would be tangent inverse y over x. Y is minus 2.4 divided by 3.56. And when you substitute all the numbers, you will find the answer is minus 34 degrees. So counterclockwise, excuse me, clockwise with respect to the positive direction of x-axis. So here. Okay, now we have a third point with the coordinates minus 2x minus 2y. X, y are here. So for this point, minus 2x minus 2y, we can say that numerical values are 7.12 and 4.8 centimeters. Okay, now again, apply these two formulas and you will find the distance from the origin for that point. So this square root, and it is equal to 8.6 centimeters. And angle theta equals to tangent inverse function, 4.8, which is y component, divided by x, 7.12. And the answer is 34 degrees. So we found this value and this value in part B. Now we found this value and this value in part C. And solve this D part at home just to train. Okay, questions? No?
No, thank you.
Great. Now, problem number 3. Now let's work with some vectors. So as you know, some parameters in physics are represented by vectors, and you covered this chapter at the lecture. So let's work with the vectors in style of math at the beginning. So we need to consider the two vectors. So first vector A is given by the form in the form of 3i hat minus 2j hat, and second vector B, which is given in the form of minus I hat minus 4j hat. Okay, we need to calculate A, first question, a sum of these two vectors, A plus B. Then we need to find A vector minus B vector. Then we need to find the absolute value of the vector A plus B. And then we need to find the absolute value of the vector A minus B. And final question would be, we need to find the directions of vectors A plus B and vector A minus B. In general, direction means that we need to find the angle with the positive direction of x-axis. Okay, now let's calculate what is given. Always at the beginning, calculate everything, not calculate, but collect everything what is given in the problem. So we have this first vector 3 times I hat minus 2j hat. B, we have a vector minus I hat minus 4j hat. So nothing else is given here. So now we need to find. So the sum a plus b. Second question, we need to find vector a minus b. C, we need to find the absolute value of vector a plus b. D, we need to find absolute value of the vector a minus vector b. And E, question E, we need to find the direction. So let's call it angle theta for vector a plus b, and angle theta for vector a minus vector b. Okay, solution. So this is a representation of a vector in a form with unit vectors. So I and j, they're unit vectors. So in a rectangular coordinate system, so let's consider 2D, so plane. We have this x and y axis. They intersect at the origin, and there are some unit vectors that are associated with these two axes. Agree? In x-axis, we have the unit vector I hat, reduce it in red, and in y-axis, we have this unit vector j hat. So the absolute value of unit vector is 1, and what is important for the unit vectors, it's their direction. So when we introduce these two unit vectors, so we know exactly what is the direction of x-axis, what is the unit, what is just one unit of x-axis. We introduce that because we know this unit vector. Now we know the direction of y-axis because we know this j vector, and now we can represent any vector in this coordinate system with these two I and j unit vectors. Okay, and in our case, we have this vector A, which is 3I hat minus 2j hat. And we have vector B, which is minus I hat minus 4j hat. So in order to find the sum of two, so A plus B, we just need to analyze their components. So we need to add this component AX plus this component BX, and that would be the X component of the sum. Agree? So AX plus BX, I hat plus AY plus BY times J hat. So this is AX, this is AX, this is AY, Y component of vector A. So here is, so this value. So this one is BX, and this is BY. So now what is the component of A? What is AX? It's 3, agree? Positive 3
Yes.
plus,
3 minus 1.
excuse me?
3 plus minus 1.
Yeah. 3 plus minus 1. So this part, it's coefficient before the A hat. Now plus AY component, it's minus 2 plus minus 4 plus minus 4 J hat. So here is minus 4, it's BY. Now let's do the simple calculation, and we will find that the answer is
2a hat minus 6j hat.
2I hat minus 6J hat. I agree, correct, yeah, sorry. So this is vector A plus vector B. So we found the first answer is here. Now the same rule with the components we can apply for the A minus B vector. That would be AX minus BX times I hat plus AY minus BY times J hat unit vector. So AX is here, BX is here, so it's 3 minus minus 1, it's 4. times I hat plus -2 minus 4. So the answer is plus 2 j hat. Agree? Is there any
Yeah.
mistake? I think no. Yeah. Huh?
No, that's right.
Thank you. So here is the answer number 2. So we found this value, this vector a minus b. So now we need to find the absolute value of this vector and the absolute value of this vector. So each vector is characterized by 2 parameters. First one is the direction, second one is absolute value. So we found the expression in the form of unit vectors. Now let's find the absolute value. So when you have the component, when you have this form, you can use just components of this vector and you will find the absolute value. Agree? So in general form, let's say, let's use vector c. So this guy is represented by cx times I hat plus cy times j hat. So in order to find the absolute value of this vector, you just need to find the square root of cx squared plus cy squared. So that's, this part is just to remind you, okay? So it's here. Now let's apply this concept of the absolute value. I hope you can understand this is simple Pythagorean theorem again. Okay, so now absolute value of a plus b vector. So what is the a plus b x component? Here it's 2, agree? So it's 2 squared plus, now a plus b vector y component, it's -6. So it's plus -6 squared. So numerical value for this expression is 6.32. Okay, so this is the answer for the part C. So part D, again, a minus b square root. Now a minus b x component. What is x component of this vector? When we have this vector represented in this form, it's 4, agree? So 4 squared plus 2 squared. So numerical value is 4.47. Okay. And now for the vector, for these two vectors, we need to find the angle between the vector and the positive direction of x-axis. So again, just tangent of the angle theta. So let me again draw this sketch here, like that, x and y. So if you have some vector, let's go c. So this guy has a component cx. This guy has a component cy. So this vector is now represented in component form. So it's cx times I hat plus cy times j hat. So in order to find this angle theta, so this is cy, this is cx. So tangent theta in general is cy divided by cx, or in general form that's just y coordinate divided by x coordinate. Okay, so from that, this angle is tangent inverse y over x. So in our particular case, we have components for both vectors a and b, and then a minus b. So this is x component, this is y component, this is x component, this is y component. Let's just substitute these numbers into this formula, and we will find out the angle. So angle theta for the sum of two vectors. So again, the sum of two vectors is here. So just tangent inverse function of what is that? So -6 divided by 2, agree? Tangent -6 divided by 2. So use some calculators, and the answer will be -71.6 degrees. Or if you wish to represent this in a positive value, just substitute 360, substitute this value, and you'll find that the answer is 288.4 degrees. So this is the angle of the vector a plus b and positive x axis. Now let's find this angle for the vector a minus b. So that will be tangent inverse. So y over x y is 2, x is 4. So y component is 2, x component is 4. That's just simply 2 over 4. Okay, numerical value is 26.6 degrees. So here is first answer, here is the second answer. Okay, questions? No questions? Okay, then let's continue.
Sorry, could you please show the paper with the solution?
This one,
Yes.
which part? Did I do a mistake? Oh, I mean,
No, the last part with the graph. Yeah, thank you.
so later I will, after the session, I will send you a scanned copy of the solution, okay? So that's just to remind you. So if you have some vector C, which is represented in component form, so this is Cx times I hat plus Cy times J hat. It means that we know the X component, which is here. We know the Y component, which is here. And we need to find this angle. Well, Y component is the length of this side of triangle. X component is the length of this side of triangle. So now let's simply find this theta. For example, we can find the tangent of the angle theta. Tangent would be equal to Cy over Cx. It's here. In more general form, we just use y and x, like y component to the x component of any vector. After that, theta would be tangent, I mean minus 1. It's inverse function of tangent, y over x. Agree? More questions, please.
May I ask a question?
Yes.
About the roundings. Like, for example, if it wasn't stated in the question, we should round angles, for example, to integers or to, like, in this case, one significant number.
Oh,
Like,
good question. So in general, I prefer to round it to this value.
okay.
I believe in syllabus, Professor Desятnikov, that so in syllabus, Professor Desятnikov sent you a syllabus. It's said that rounding should be plus minus some few percent, something like that. Yeah.
Yes, 1% it was.
So, and if your angle is more than 20, 30 degrees, then you can round it to the integer, I believe.
Okay, thank you.
But in general, that's a good question, because you know this form. So 20. So for example, this 26.6 degrees. At high school, we represented angles, for example, in the form degrees, then something minutes, and then seconds. Yeah. So minutes will be 6/10 times 60 minutes. Around to integer, I believe it's okay.
Okay.
So 1027, here is 288. If there will be some mistake, not mistake, if there will be some wrong answer in Moodle, you will argue with Professor Desятnikov.
Okay, thank you.
So more questions? By the way, you can also send me your question by email before the session, after the session, okay? So what is the next problem? So which one was solved? Oh, okay, so next problem is as follows. So now here we have a text description of the vector. We need to solve something with this description. So now it is given that vector A has a negative x component 3 units in length and a positive y component 2 units in length. First, we need to determine an expression for A vector in unit vector notation. Then we need to determine the magnitude and direction of A. And third question is as follows. What vector B, when added to A, gives a resultant vector with no x component and a negative y component for units in length. Okay, so given. So let's do it like that. So let's draw it. Let's start our solution. So vector A has a negative x component 3 units. So what is the x component of vector A? So it's -3, agree? Because x negative is 3, that's why x component is -3. So y component of this vector
It's 2.
is 2 units, it's 2. Yeah? Now we can immediately answer the first question. Determine an expression for the vector in unit vector notation. So in unit vector notation, vector A is represented as ax times I hat plus ay, so y component, times j hat. So answer is -3 times I hat plus 2 times j hat. Okay, so it was at the given ax is -3, ay is 2. So we already saw this first part A, but let's collect all the needed information at the given box and question box. So in A, we had to find a vector A with A hat and J hat. So B, we will need to find the absolute value and this angle theta that vector forms with the positive direction of x axis. And C, now let's analyze the part C and let's represent the question in this form. So what vector B when added to A gives a resultant vector with no x component and a negative y component 4 units in length. So when we add to the vector A some vector B, that would be a resultant vector R, and this resultant vector doesn't have x component, which means that Rx, this resultant vector, is 0, agree? And Ry, y component, is 4 units, is 4. So it's given. We need to find vector B.
It is
Agree?
not -4.
Maybe, let me check. Negative, yes, thank you, it's negative. So it's -4. Thank you. So first I have to look at this piece of paper, at the monitor, at the text itself. So please follow me and check me. I sometimes do a typo. So
Sorry, what is the magnitude of the vector, like in B? In B condition.
excuse me, in B, we just need to determine the magnitude of vector A.
And what is it? I just don't remember.
Oh, I'm going to show you because we're now solving part B. So part B, magnitude. So each vector, again, has a specific direction. Yeah, let's say this vector C. It has a direction and it has the magnitude. Magnitude is just absolute value, the length of this arrow. So this is magnitude. Okay. And if you have the vector represented in this form, Cx plus Cy, what would be the magnitude if we know the components? Colleagues? Just square root of Cx squared plus Cy squared. Agree? So do you want me to explain in more details why it is like that? And what is the magnitude?
No, it's
Okay.
Pythagorean theorem.
Pythagorean theorem, yes. So because when we have this representation in I and J components, it means that we introduce some coordinate system like that. So this is x, this is y. So Cx means that in x-axis we have this Cx value, and y-axis we have this value, Cy. And if you look at this triangle, so let me replace this guy like that. Absolute value. If you look at this triangle, you will find just Pythagorean theorem. So Cy squared plus Cx squared equals to the absolute value squared. So in order to find this absolute value, just find the square root of this sum. Okay, so the next week you will cover some one-dimensional and two-dimensional motion, and you will introduce a parameter of the motion as velocity and speed. Speed would be the absolute value of the velocity, and the velocity would be a vector. So a vector means that you know the direction of the motion. So when you drive your car, you look at the speedometer. You know that at the speedometer, all the values are positive. There is nothing about the direction. It's magnitude of your velocity. But when you know the direction, for example, you're going to the airport. Now you can say your motion in terms of the vectors. So you know your direction and you know the absolute value. So this is a magnitude of the velocity. And in this particular case, this is just pure math. We're just discussing the absolute value or magnitude of the vector. So now we have this, we found this vector A in unit vector form. The Cx is just this, again, to remind you. Okay. Now we need to find the absolute value of A, which is represented by this form in unit vectors. So now we can easily substitute these numbers into this formula, and that would be, what is the AX component? It's minus 3 squared plus 2 squared. Agree? And the absolute value is 3.61. That's the absolute value. And we need to find the angle. So the direction means that we need to find the angle. And again, just a tangent of the function, do it at home, you will find that theta is 146.3 degrees. So let me draw it here, just to show you where the vector is located. So vector is located, it has negative x component, it's minus 3. So it's here. And positive y component, it's here. So it's 3 minus 3. This is plus 2. So this vector is originated from the origin, and it is directed to this point. So this is vector A. Okay. And just look at the components of the vector, and you will find this angle theta. Theta is here. Now let's solve the final part of this problem. So it's given that A plus B gives you resultant vector R, and this resultant vector doesn't have X component, but has Y component. And we need to find the vector B that we should sum to the vector A. So Rx component is 0, Ry component is minus 4, and also we know that R is a result of A plus B, but we need to find vector B, it's question. So from that, B equals to R minus A. And then just use the component rule, you will find that B is equal to Rx minus AX times I hat plus Ry minus AY times J hat. And now we know everything in this form. So Rx is given, it's 0. AX we found before, it's minus 3. Ry is given in the problem, it's here. Ay we found in first part of the problem. Now we can easily define the B vector in the form of unit vectors. Okay, so B is just, so Rx is 0 minus 3 times I hat plus minus 4 minus 2 J hat. So now vector B has a form of 3 times I hat minus 6 j hat. Here is the answer. So that was the answer for part B. This is for part C. Okay, questions? Oh, we don't have a time, but I can solve. So the final
Sorry, I
problem.
have a question.
Okay.
Could you please explain the part with um, the B part with the graph?
The P part, you mean this?
Yeah. How
Okay.
did you find the degree of the vector?
Oh, okay. So when I look,
Because I got another answer.
so first, you should keep in mind that tangent function has a different period than cosine and sine functions. Agree? So I understand you got with calculator you got different number, but analyze the graph at the beginning. So the position of the vector A is here for sure. So how I solved it by myself? So first so this is vector A. Let me please remove this guy. This is vector A. So this is vector A. So I know this component. Yeah, I know, let's see, this component. So this one is minus 3. This, excuse me, plus 3. So now it's component plus 3. This is plus 2. So first, let's find this angle alpha. So always try to work with, when you need to find tangent of some angle, first find the tangent for the angle which is less than 90 degrees. So in this case, this angle is larger than 90 degrees theta. So first find this angle, alpha. So tangent would be, so this alpha intermediate result. Tangent is what? It's tangent alpha is 3/2. 3/2. So from that, this angle alpha would be 56.3 degrees. Okay, and then final angle theta is just alpha plus 90 degrees. So that's how I found that the answer is 146.3 degrees. So from trigonometry, you need to follow the rule that tangent has different period than cosine and sine. So it is better to work first with the angles less than 90 degrees to be sure that you solve correctly, not just mathematics, but also this part. So is it clear how I found this answer? So first I found
Yes.
this angle theta, then I
Not
just
clear.
sum of alpha plus 90 degrees. Okay. So if you have time, the next problem is related to physics more than the previous problems, because the previous problems were about the math. So let me briefly, and the final problem is short, but now we're going to introduce a first derivative with respect of time of some vector. So let me first read this problem. So the instantaneous position of an object is specified by its position vector leading from a fixed origin to the location of the object, modeled as a particle. Suppose for a certain object, the position vector is a function of time given by this form. So R vector, position vector R is 4 in the problem times I hat plus 3 times J hat minus 2 T K hat. Now we have 3D space. Okay, now we have this unit vector in Z axis. So where R is in meters and T is in seconds here. We need first evaluate dr dt. So first derivative of vector R with respect to time. And we need to answer the question, what physics quantity does dr dt represent about the object? So physics. And in general, in this problem, we introduce a concept of position vector of some point. So let's just solve this problem. Let me briefly remind you that if you have some vector, let's say vector A in this form, AX times A hat plus AY times J hat plus what was that, Z times K hat. So you have this vector, which is represented in unit vector forms. In order to find this dA dt, a first derivative with respect to time, you just need to find the first derivative of each component and then multiply by the unit vector. So it is equal to dAx dt times I hat, excuse me, plus dAi dt times J hat plus dAz dt times K hat. So because AX, AY, and AZ, they can be a function of time, like here in this given problem. So now let's use this rule and let's find dr dt for the given number, for the given vector. So now dr dt. So what is the x component of vector r? So it's just 4, agree? So that will be d dt of number 4 times I hat. So it is not a function of time. So that's why this component would be 0. Agree? The same for the y component of vector r. So this is, let me introduce it here. So this is rx, this is ry, and this 2t is rc. So that would be 0 for the j component, ddt, or just simple number 3 times j. Again, it's 0. Plus, now the z component is not, now the z component is a function of time. So that is d dt of this function minus 2t times k hat. So what is d dt of minus 2t? It's just minus 2, agree? So from that, dr dt equals to minus 2 times k hat. So dr dt, first derivative of this vector with respect to time, is also a vector, which has only z component, minus 2k. So this is simple vector. Now let's analyze what does it mean, dr dt. So this is a position of the vector, of the point. It's a position vector. Now let's introduce this coordinate system. Let's say x, now y, and third dimension is z. So position vector at the beginning was like that. Yeah. So let's consider the position of the object at the instant of time t equals 0. So when t equals 0, position vector is just for I plus 3j. Agree? So now let's draw it at the t equals 0 at the initial moment of time. So it's 3 or 4 I x component and 3j. So it's 1, 2, 3 here, 3 and 4. So position, so the point was here. That was a position vector r0. Can you see? Yes. So now let's what will happen in t equals 1 second. Now the same components and x and y directions, but new component minus 2 in z direction. So this guy would be the same here. This guy would be the same, but that would be minus 2. So the point would be here. Agree? This is minus 2. And vector, position vector, that was r0. Position vector now would be directed like that. That is r1. And every second, step by step, so in next second, the point will move here again by a factor of minus 2. That would be minus 4. It move further and further. And every time position vector would be directed like that, like that. And this dr dt represents you a vector of velocity. So that's a physical meaning, okay? So this is velocity vector. So if you draw point here, this velocity would be minus 2k. Minus 2k. Oh, excuse me, head. At any instant of time, the speed would be, velocity would be minus 2k, which is dr position vector over dt. So questions, please. No question? So then, thank you for your attention. Later, maybe tomorrow, I will send you the solution, these papers by email. See you next week. Thank you for your attention. Thank you.
Sorry, can I ask?
Excuse me, sir.
Yes, just Marat, sir.
Thank you.
Thank you.
Goodbye.
Yeah, so if you don't have question, the questions, yes, please.
Sir, look, I just wanted to ask, are you going to share this recording?
I can share, yes.
I mean, it would be just great if you do this,
Yes, okay.
or just to revising stuff.
Yes, then I will send you by email this recording and also solution, and you will be able to follow with the recording all the writings in paper. Okay.
Oh yeah, that would be great. That would be great, sir.
Okay, and also
Thank you very
if
much.
if you send me questions also by email, so let's discuss physics. And I hope you will all get the highest possible grade for physics 161. I wish you that.
Yes, thank you. Goodbye.
Okay, more questions, please. No?
No, thank you. Bye.
Okay, bye-bye. Bye-bye.
Thank you very much. Goodbye.
You're welcome.
Thank you, sir.
Just
Have a nice
Marat,
weekend.
not sir. Thank you. Bye-bye.